Okay, now we're going to try to use stochastic gradient descent to actually learn those proportions. So here we've made a basic training loop. You've gone through this in Lab 2, but I've made a few mistakes as we set this up. But I'll first walk through it as if we didn't make a mistake, and then we'll see what mistakes we made by what errors we get. So the first thing we're going to do is redefine these parameters, but we're going to define them in such a way that we just initialize them to a reasonable value to start with. We're going to start with a 111, divide them by 3 so that each box has 1/3, 1/3, 1/3. And then we set the requires grad parameter on params so that when PyTorch is running through all of these calculations based on these parameters, it's going to keep track of the adjoints, the functions that it's going to need to run our backpropagation. So now we're going to define a list of where we're going to keep track of these scores as we get them. So each round, we're hopefully going to get a better and better score as we learn more about what these proportions are. And we're going to do 50 rounds. So each round, we're going to pick a box, or the friend will pick a box, and I'll get to see which box that is, and I'll make a guess at what proportions of beads we're going to see. So that get guess calls this function that we defined up here to get guess from a box, except it's going to use the parameters that were defined down here rather than the ones up here, just because of it's going to use whatever that params is named in the global namespace. That's fine. So we're going to get guess using that. Maybe I should have named, actually, this is a good habit. We should make explicit how information flows. So let's pass the params onto our get guess here. So that means I'm going to need to change this guess is going to need to take params and get params for the box. And then we need to pass that on params here. Okay, so I didn't change anything here except I just passed that params along to the get guess function. This is a good habit to do, just to really make your data flow explicit, so that this function doesn't depend on any global scope. So sorry, I had that wrong the first time. So the first thing we're going to do, once I have a guess, is I'm just going to make sure that guess is valid. What is a valid guess? Well, a valid guess shouldn't give 0 or less than 0 probability to anything. I guess it's okay if it gives 0 probability. So I'm just going to put in a greater than or equal to here. So all of the guesses should be greater than or equal to 0. And the sum of the guesses should be 1. Well, I'm actually going to allow it to be something different than 1. So we'll take the sum and subtract 1.0. And if the absolute value of that difference is less than 0.01, we'll say it's okay. Maybe I should really want to tighten this up and make it 0.001 or something. But still, we don't want to be tripped off by just small numerical precision errors here. Then I'm going to draw 10 beads. Why 10? We'll see. And then, so my friend draws a bunch of beads, draws 10 beads for me, and they compute the score of how well did I do. So I made a guess. How well did I do at these actual beads that the friend drew from that box? Whatever that score was, we're going to keep track of it in the scores list. Now I get to look at what actually happened and said, okay, how could I have done better at that? So I call backprop. I backward the score, so I can figure out what change to parameters would affect the score. So this is computing the gradient of the score with respect to each of the parameters. Sorry, the gradient of the parameters with respect to the score. So what should I change these parameters to? Now I'm going to update the data of the parameters. So this is making an update that is not going to get tracked by the backprop thing with respect to the parameters. And then this loop is going to run 50 times, and we're going to plot the scores. It'll turn out that this will crash pretty soon, but if this didn't crash, we'll be able to look at what were the proportions that we guessed, and these should match up with the true proportions that we computed up here, if we did an effective job at learning and evaluating our learning. So I'm going to run this, and the very first thing we notice is an assertion error. What assertion error? So we're going to practice debugging. We're going to figure out what went wrong. So we're looking at line 10 failed. So this assertion that all of the parameters were, all of the guesses were greater than 0. So what failed? So now you can think about this a while, or you can just inspect what actually happened. So let's look at the executed code history. And this now gives us a way to just run single things in here without needing to add cells. If you're running in plain Jupyter Notebook, you can add a cell at the end here just as a scrap cell to have, but you just need to remember to clean them up later. But I'm going to poke at things here. So what actually happened? The first thing I'm going to look at is, it says my guess greater than or equal to 0 dot all. So I think that means that there was a guess that was negative, but I want to look at it. I want to check it. Which guess was negative? Oops. Keep here. Type code to execute. So I'm going to just type my guess. I'm going to look at that value. What does that value have? Ah, there's a negative value there. Okay. Um, so yeah, that assertion correctly failed. Something was wrong. We shouldn't have had a negative value. Where where did this happen? What step did it happen on? It happened on step 2. Okay, interesting. Um, so sometimes it's good to just say, well, this failed. Is it reproducible? So I need to know that if I fix something, is it actually fixing it? So I want to first make sure that I can reproduce the error, and then I'll be able to know that once I've fixed the bug, it's actually fixed. So I'm going to rerun. Notice that it starts with a manual seed. So this is important that it'll be able to make a consistent state as we're going through this. So I'm going to run this whole thing again. Since I've been poking at things and running some code cells out of order, this might actually give a different result this time. Yeah, my example beads was a little bit different here. Oops, and I did it again. Let me just run all. Um, in fact, restart and run all is a good habit to do. Let me just make sure that this error reproduces the very next time I try to run. And it looks like I accidentally changed this to a markdown cell instead of a code cell. So let me flip that back. So I think it's Control P, no, Control Shift P. Yep, and then I say code and convert to code cell. Yep, there it is. So I had accidentally hit the wrong key, but I fixed it. All right, so now we have an assertion error on the same place. Let's see, did we get the same problem? So this time it was same error, and my guess was indeed this negative thing. Okay, so we need to make sure that that our guesses are always greater than 0. Um, so how could we do that? Um, well, so what happened? Somehow the parameters that we used for our get guess, we're just pulling something straight out of the parameters for that box. So if we look at the params, then here's our problem. Box 0 got these bad parameters here. Um, hmm. So somehow we took a step that took us from reasonable into completely unreasonable. Um, Now you can do a couple of things here. Sometimes when I've set this up, I've ended up with just the difference from a probability of 1, and you could try you know, dividing this by the sum to renormalize it as a probability distribution. But that won't work if we're less than 0. Some people will say, well, let's take the absolute value of this. And let's just for grins, let's see if it works. So I suspect this might actually work. In fact, it's a valid parameterization of this problem. It's just a little bit awkward, and this isn't going to solve our second problem. So let's see if we hit our second problem first. Restart and run all. Go. Okay, yeah. So now we did sort of with a blunt hammer, we forced everything to be greater than a 0. Didn't necessarily make that mathematically meaningful, but sure, just make them all greater than 0. But now we don't have them summed to 1. Okay, so let's just look at what our guess was here, and indeed they sum to not even half. Okay, so clearly we need a slightly better thing to do here. So one of their recent fundamentals notebooks dealt with how to work with the softmax function. So basically what a softmax function is going to do is it is that function that takes any parameters, even some that might be negative or whatever, and makes it so that it's a valid probability distribution. It makes it so that nothing is negative and it all sums to 1. So, for example, if we take the param 0, that's our first box. That's the one that we know. Okay, that sums to 1, but okay, I guess it's the second box that we had. Um, oh, I reran this line. Maybe I should split this up so that we can uh, um, redefine this function without affecting our whole parameters. This is also generally good practice when you're debugging one thing per code cell. So, and I didn't do that very well in this initial setup, so that we got confused by rerunning this cell, reinitialize the parameters. Let's split this up. So how do I split it up? If I remember the keyboard shortcuts, that would be great, but Control-Shift-P is the run anything in Colab, and then we should be able to split at cursor. There we go. So now we can get guesses here, and I'm a little confused where we are, so I'm just going to restart and run all. Notice how often I'm doing this. Restart and run all. Okay, we hit our assertion error again. Now I can double check that indeed our params was this, and yeah, here's our negative numbers. So let's look at param 0. Oops, params at 0. Param 0. So that thing is all negative, doesn't sum to 1. Dot softmax. I need to tell it which dimension to run on. Dimension 0. Now, notice that none of those are negative, and their sum is 1. Great. So I could use the softmax function as a way of mapping whatever these numbers were into something that that is a valid probability distribution. So expand all sections again. Here we go. So let me just go back in here. And instead of doing this hacky absolute value thing, I'm going to need to actually do what this comment suggests and ensure that the result is a valid probability distribution. So let me delete this thing and leave the comment there. And I'll use my .softmax that I pasted here. Does this work? Yeah. So option up and down arrow exchanges lines around, so it's a nice and easy way to edit things. So now I'm going to try running this this guess again, and regardless of which box I give, I get a output here that looks like a valid probability distribution. It looks pretty good. Okay, so let's try this again. What should we do? Restart and run all. And now it looks like, oh, right, I forgot to pass the params in here. Guess for our new params and box 1. Whoops. Okay, so kind of looks pretty wacky here. So we've got code that runs, but its output doesn't look right. So now we're getting into some interesting numerical computation debugging. So tune back again for the next video, and we'll go through how to do that.